If we pick up a stone and then let it go, why does it fall to the ground? The special and general theory of relativity. This question from Einstein dates back to 1915. In 100 years we did not find a clear answer.
Falling objects on the surface of the Earth fall with an accelerated velocity of about 9.8 meters per second squared. This video will present a possible explanation. It will explain that the acceleration at the surface may be the result of an in-stream of the energy field towards the center of mass from planets to atoms, and cause a slightly increase of matter. The acceleration of objects at 9.8 meters per second squared at the surface of the Earth is partly caused by dragging the objects to the center and partly caused by an increase of the radius of the Earth. Probably this conversion from energy to mass causes an increase of our Earth in accordance with many other theories that propose that the Earth is slightly increasing.
I found an important equation in Einstein's paper The Principle of Relativity, a collection of original papers on the special and general theory of relativity. Einstein chooses centimeter and gram instead of meter and kilogram. That's why he counts on 10 to the minus 27. In the KMS system we read this equation with a result in meter per kilogram. The coupling constant kappa equals 8 times pi times the gravitational constant divided by the light speed squared. The gravitational constant is an important factor with respect to the acceleration at the surface. So, let's rearrange that equation from Einstein and start with the gravitational constant instead of kappa. We get, the gravitational constant equals c squared times kappa divided by 8 pi. Let's check. This is mathematically not really a surprise and the result proves that the equation is valid. But this formation of the gravitational constant is really different from the in quotidian used Newtonian equation. Acceleration at the surface is the result of g times mass divided by the radius squared. Instead of one gravitational constant we got now a splitted gravitational constant with two parts. We got now two parts A and B. A with kinetic energy half mc squared and B with the Einsteinian coupling constant kappa. And that presents a quite different view of the in quotidian used Newtonian equation. I know. Occam's razor says that you should use the most simple form of an equation, but sometimes this simple form will hide what is really going on. Let's check this equation with the splitted gravitational constant by calculating the acceleration at the surface in this way. This is more complicated, but the result for the acceleration at the surface is exactly the same, 9.81 meters per second squared. Could it be true that the measured acceleration at 9.8 meters per second squared at the Earth's surface is a combination of two factors A and B? What would these parts A and B represent? Is there a physical interpretation possible? Yes, I think there is. A. The downstream energy that flows from outside the mass to the center of the mass. B. The upward movement of the surface area that expands because mass is increasing by the conversion of energy to mass. The mass of the Earth is slightly increased by the absorbed energy field. The Earth is increased by that energy and causes a tiny expansion. Over millions of years the expansion causes ocean rifts, drift of continents, eruptions of lava and earthquakes. The downstream causes the stone to fall. The energy stream is dragging the atoms of the stone in the direction of the center of the Earth. The in-streaming matter energy field and the expansion that is the result of the conversion from this field to mass. You can imagine this. There is a stream of water in front of you that is streaming down. You put your hand in the stream, you feel the stream pulling your hand down. This is like the pushing down in stream at the Earth's surface. Now you push your hand slowly upward, that is like feeling the tiny expansion. The force on your hand increases, but it feels like the same force. Together it is that acceleration at 9.81 meters per second squared. Now stretch your arm, feel the weight of your hand. Can you imagine that the force that you feel is a combination of downstream dragging and a tiny upward pushing? There are several theories that support the idea of an inflow of energy towards the center of mass, be it a planet or an electron. If we don't have a clear answer on the question about the falling stone, I presume that every theory can be wrong or right, as all theory is built on quicksand. This theory is explained in an extended book that you can download for free. From there you can also download detailed calculations based on the coupling constant kappa from Einstein and many other calculations. Just think about it and draw your own conclusions.
Dragging down, and a tiny upward expansion. Dragging down, and a tiny upward expansion.